In this video, we are going to learn about how to design a schematic symbol and PCB footprint for through-hole RGB LED. Hi everyone, I am Vaibhav Sugandhi, co-creator at Linked Frequency. There are 4 steps involved in this entire components library design activity. First one is identifying the right datasheet. Make sure that you download the datasheet from the authentic source, otherwise you will end up in a wrong direction. Second step is creating a schematic symbol using EasyEDA. Third step is creating a PCB footprint using EasyEDA. Both are different steps and done in a different time wizard. The fourth step is all about combining schematic symbol and PCB footprint so that you can create a library which you can use for any project in the future scope. So let's start with the screen recording and head towards the EasyEDA. I have downloaded the datasheet of 5mm RGB LED, a through-hole component from the Google. This is a manufacturer datasheet. Make sure that you download the manufacturer datasheet which you are using in your locality. The first thing which we have to identify in this datasheet is schematic representation or a schematic symbol. In this datasheet, every datasheet will be different, but in this datasheet, if you scroll down on the dimension page or maybe a mechanical data page, the same way or on the same page, they have given the schematic representation of this particular component, which has a first pin as a red color, second pin as a cathode, and third pin is a blue color, and fourth pin is a green color. This is the schematic symbolic representation of this particular component. And it's a common cathode LED, that's why all the cathodes are connected. If it is a common anode, then it will be in a different way. Now I will head towards the EasyEDA and I'll go to the file section, create a new symbol. Remember, we are not going to create a new schematic, we are going to create a symbol. So when I click on that, this wizard will appear to you, and this is extremely similar to the schematic symbol or schematic representation. What we are going to do is, we are going to zoom into the origin point where the entire sheet is having a 0,0 coordinates. There we are going to place these pins. The placement of these pins should be done in such a way that the ring which is attached to the cursor should be outside. That is where the wires are connected. So I'll rotate and place first number pin somewhere here because RGB LED. So first pin is a red color, second pin is common cathode, third pin is one color, fourth pin is another color, maybe blue and green, right? So I'm going to arrange them in a little bit better way like this. And I'm going to save this schematic symbol first before jumping into any further step. I'm going to save it in my account and I give a title as RGB LED underscore 5mm, just to indicate it is a 5mm outer diameter. Supplier part number or supplier name should be mentioned if you are very sure from where you are procuring them. Right now, I'm not sure on that, so I'm not going to mention it, but it is always better to mention these details in your schematic symbol. The manufacturer, which we already know, the manufacturer of this particular component is Multicomp Pro. So I'll type it out. Multicomp Pro, and manufacturing part number which is given in the datasheet, you must identify the right part number because that is the most important part to order when you are ordering the component. So this is the part number. Selection guide is one table where you will get the part number. This has only one part number because it is simple RGB LED. That's why we are going to copy this part number and paste it here. The link of this datasheet can be given or cannot be given. It's your choice. The tags, which I'm going to split this as a LED, so I'm going to name it as a LED tag. Description, I'm going to write this as 5mm round RGB LED. We can add THT in between here, so that indicates it's a through hole. And along with that, I have a small tips for you. To make sure that these libraries are easily available for others or anybody who is designing in your own company or a startup or in your team only, you can add your name here. Adding a colon and adding your name will make it easy to search. When you go to the global library, if you search my name, Vaibhav Sugandhi, then you will quickly get to know all the libraries that I have designed. Cool it is, right? And then I'll save it. So every 5 minutes or every 1 minute, I'll keep on hitting the Ctrl S so that it will be saved automatically. And I do not lose the design if anything goes wrong with my computer. So let's start with the next process. The next process is to indicate or create LED shapes using the line tool and different tools available over there. But one important thing is I need to change the grid size. Otherwise what happens, my LED size will be too much big, just like this. This is too big size LED indication. Rather than that, I would like to make it as a smaller one. So how do I do that? I'll change the grid size, and when we change the grid size, we are not going to move these connect points or the pins actually, because pins should be placed with a grid size of 10 mils actually. It is mentioned in mils actually. So these are the 10 mils placement of the pins actually. So I'll just change it to 5, and I'll change the snap size as well 5. And now I will draw the LED indication here. Just randomly anywhere I will draw it. Later on I'll change it however I want it actually. I'll just make sure that all are equally designed. You can copy paste them as well, but I prefer to draw them. Once we are done with that, I'll just drag them. Only these representation circuits or representation symbols can be moved or can be designed with a 5 mils grid, not the connect points or connecting pins, because it will be very difficult to use that particular symbol in schematic diagram. That's why. So what I'm going to do is I'm going to change the grid size or a snap size to 10 again, both of them, and then I'll see if I can move this particular pins. I think they are at the right place. I do not want to move them anyway. So 2 grid from this side, I'll just reduce it to 1 grid, just to make sure that the symbol is in very right direction or right placement. So I'll reduce this one to 2 only. I'll keep it as a 2 only, and I'll change the name of these particular pins. First number pin name is, if you go to the data sheet, you will get to know that what is the pin name. The first pin is red color, so I will mention it as a capital R, but and then I'll just display name should be disabled. It is okay to disable it. If you want, you can keep it. Otherwise, you can disable it actually. So the third pin is B, which is blue, and after changing the name or after giving the name also, I'm disabling it. The reason is the name should be given for a proper or professional schematic symbol design, but whether you want to display it or not is your choice. But giving the name is always a good practice. So fourth one is green color, so I'll give a capital G and display name to no. And here it is a cathode, so I'll just write a capital C and display name to no actually. So I'll save it once again, and now again I'll go back to the grid size of 5 and snap size of 5. Why? Because we want to create a wire for connecting these points, right? So I'll just create something like this, and this one, and this one, and then cathode side this one. So once all these things are done, obviously we need to connect all these cathodes, so I'm going to create a connection like this. So once we are done with that, I'll save it, and again I'll come back and change the grid size. This is very important. So you need to change the grid size and snap size as soon as you are done with the designing activity. These are called designing activity, wherein the placement of the pins should be done on the 10 mil grid. Remember this one. So now I'll change the color of these LEDs so that it looks realistic and it is easy for someone to figure it out what exactly they are using, like whether they are using a red color or green color, blue color. The third pin is a blue color one, so I'll change it to blue color, fill color to blue color so that it looks exactly blue, completely blue. And then we have a green color, the fill color to green color. Alright, this looks very good actually. You can add a rectangular, circular shape on the border of this particular symbol and make it even more beautifying. But right now I'm not focusing on that. This is how you need to create your entire schematic symbol. There are certain settings which you have to do after this. First setting is making sure that add to BOM is set to be yes. Why? Because you want this entire component to be on the BOM when you design a product. And you have to keep the convert to PCB as well as, otherwise what happens when you use this symbol for designing a schematic, but if you go to the PCB layout, it will be not visible to you, or it will be not having its own footprint on the PCB layout side, which we don't want. We want entire package, right? So I need to make sure that it is available on the PCB side as well. Name should be given properly, which we have given while saving it, so nothing to worry about it. Footprint, we'll assign it later when we design it, but right now we'll keep it empty. Pre, which is nothing but a designator or a prefix. So we need to change this prefix according to our schematic symbol. For every symbol, for every symbolical representation of electrical and electronic component, there is a standard to maintain for this. You can refer IEEE standard or IPC standard to understand how to name them. For LEDs, obviously it is LED and question mark. Question mark is mandatory. Why? Because it will increase the count. If you use one component or one RGB LED, then it will give a LED 1, which is a designator. And if you use another of the same symbol, then it will give a LED 2. These designator count increases because of this question mark. That is the script running behind this EasyEDA software. So we have to maintain it. And again, these things we already discussed, so I'm not going to discuss on that. So these are the things which you have to update while you are completing the entire schematic symbol. I hope you understood and I hope you designed it by yourself. Once you are done with that, we'll go to the next step. Now it is time to go for the PCB footprint design. How we do that? We need to figure out the dimensions first in our datasheet. This is some tricky part and it requires a basic mathematical calculation and understanding the coordination geometry or the coordinate system of the graphs and all that thing. So I hope you all understand this basic mathematics. If not, then feel free to understand them and then design these PCB footprints and all. The important part here is this is the data which we have right now in front of us. This is the data we have. And you can see here, first thing is inner diameter of the entire LED, which is the inner circle of the duct of the LED, is 5 mm. That's why it is so called 5 mm RGB LED. Outer diameter is 5.8 mm. The tricky part is it has a small notch here. I hope you can see this one, right? So that small notch indicates where is the pin number 1, which is very important. Why? Because if you scroll a little bit down, you can see here the cut part of this particular LED here indicates the notch from this angle, from viewing this angle, and that is the first pin of the LED. And first pin of the LED is R pin actually, which is red color pin. And if you by mistake assuming all are 4 pins, so if you insert it like this or like this, everything is same. If you assume like that and makes a first pin as the 4th pin, because that is how our numbering system starts, 1, 2, 3, right? So if you misunderstand this one, then your entire LED is going to be not working on the PCB when you solder it. Why? Because it's wrong actually. The cathode is not connected to cathode, anode is not connected to anode, then it doesn't lit the LEDs. So that's why we need to understand where is the first pin. That is first process. So second thing is identifying the dimensions, the pitch of the LED or pitch of the lids from one point to another point. According to this diagram, the lid thickness is 0.5 mm. Why mm? Because it is given very clearly in bottom here. So all dimensions are in millimeters. Okay, I'll zoom out a little bit so that it is easy for you to see. So 0.5 mm is a lid thickness. That is a one data point. The second data point is the distance from one point to another point is given as 1.25 mm. Why? Because the distance, so center of the 4th pin to the center of the first pin is 3.75 mm. If I divide it by 3, it will be 1.25 mm, or directly it is given over there. Now we need to head towards the EasyEDA and design it. This is where the tricky part comes and very interesting one. I'll go to the file, go to the new, create a footprint. This looks exactly like a PCB layout, but it is not a PCB layout. Options are a little different, so be careful on this part. So first thing is I'll save it because that is the first process. So title, I'll give it as a THT RGB LED. Okay, and the tag is LED only. Link, I'm not going to give anything right now, and description is again referred or copied from the schematic symbol that we recently created. So that's a beautiful part. And again, I'll give my name here so that whenever somebody search for my name, they will get all the footprints I have designed in my account, and they can use it for their purpose. I'll save it. Now I will take the pad from here, or you can press a P key on your keyboard also, shortcut. I'll place a first pin number here. Why here? Because we have seen it on the data sheet, right? First, second, third, fourth. All right. And I'll select all of them and I'll make sure that in Y direction, they are all on the 0th position. They are all on the on origin position with respect to Y direction. With respect to X direction, we'll discuss all that. First thing is, we cannot place these pads very close to each other. If they are touching each other, then it is a short circuit. That's why I'm going to change the round size of the pad to the oval size and make a width as 0.8 mm because we want 0.5 mm drill hole, and upon that a little 0.8 mm is sufficient. And also pitch is very less, so that's why 0.8 mm is sufficient. But the height I'm going to make it as a 2 mm so that it is very good soldering position. We can solder it properly, the lids can be soldered properly. And then a drill hole as 0.6 mm because that's what we want. 0.5 mm is what they are mentioning. Tolerance of 0.1 mm is sufficient. I'll just do it similarly for all the three of them. I can select all of them and make them at a time. 0.8 mm is the width, height is 2 mm, a drill hole is going to be 0.6 mm. Hala, done with this. So now the first part is, we know the distance from one pin to another pin is 1.25. But with respect to the mid origin, we need to divide it. That's the tricky part. It's a simple one, nothing much to worry about it. So I'll open the calculator and I'll calculate 1.25 divided by 2. Even though if it is a simple mathematics, do not do it in your mind, use the calculator because all the three digits need to be entered here for the accuracy and the professional designing of PCB footprint. So 0.625, right? So I'll select this one, I'll place it at 0.625 and I'll select this one, make it as a minus 0.625. Understood? I hope you understood this point actually. And total distance from the center of this one to this one is 1.25. Now we got these values, we need to add 1.25 to those values and make these points positioning on that side. So 0.625 plus 1.25, it is 1.875. So I'll select this one, make it as 1.875, 1.875. All right. This side also, I'll select this and make it as a minus 1.875. Hala, we are done with this PCB footprint. This is all it is actually. Mathematics wise, it is simple one, so it's quite simple. The only thing is we need to mention the circle right now so that we can create a notch and indicate it as the PCB footprint, right? I'll use the circle option directly and I'll make sure it is on the top silk layer, not on the top copper layer, top silk layer, okay? And I will draw a circle like this, random circle, and I'll change the values afterwards, after selecting that. 0.127 stroke width is sufficient and radius is going to be 2.5 because it is a 5 mm LED, diameter is 5 mm. And upon that we have one more thing which can be having a cut on the one side. So that's why we cannot draw a complete circle for that. Instead, I'll use a arc center circle. So I'll make a center here and I will start drawing from, this is a problem. We need to start drawing from that side. That's okay, no problem. I'll just change it afterwards. So I'll select the part and make it as a 0.127 and then radius is going to be how much? Total it is having 5.8. So 5.8 divided by 2 is 2.9. So I'll just make it as a 2.9 first thing. And the length of this entire arc will be 10. No, not 10. So it will be somewhere around 20 probably. Not 20. 15 I guess. Oh, sorry, 15. Okay, let's keep it as a 15 right now. I'll see it how to do it later. 330 or 30. Probably 30. Yes, starting point should be 30 and ending point should be 330. How do I know that? It's just a practice. You can practice it and you can do it as well. So length, I'll not change it because that is there actually. So clockwise, anti-clockwise, locked, unlocked, that's fine actually. And then in the top silk layer only, I will join these two ends by using the line track actually, or maybe the track symbol. So 0.127 and starting point, end point, all that thing is fine. So this is how our footprint is ready. Now what we need to do is, we need to link this footprint with the schematic symbol that we have designed. So let's do it. For that, what we need to do is, we need to go to the schematic symbol that we have recently designed or whatever we want to assign to. And then here we can see the footprint section, right? So I'll select it, I'll click on that particular option and I'll search for THT RGB. When you search in the global search option, you can see the workspace option, or if you change it to any other contribution, user contribution or LCSC or system or follow, you will get the different footprint. You can assign others' footprint to your schematic symbol, or you can assign your footprint to others' schematic symbol. All that permutation combination is possible. But right now, we want it in workspace, because workspace is all about our own library. I have designed a lot of THT component footprint. So that's why it is showing here. For you, it will be showing only this component, which we have just now recently designed. So I'll just double click on that and it is assigned. You can see that. And if you go to the pad size, you can see the pitch of the the LED's pins is going to be 1.25, which is recommended by datasheet. And then I'll update a footprint. Not necessary, but if you want, you can just confirm it once again. And then I'll come back and I'll save the schematic symbol. That's it. You are done with creating a first component library in EasyEDA. How we use this one? I'll go to the schematic. I'll create a new dummy schematic, just not to save it, just to show you how to use it. So I'll come here, and in symbol section and in your workspace section, you can see you have created one particular schematic symbol and also package, which is footprint. So when I select that, you can see both will be appearing to you. And when I click on the place, you can see here, you can place and use this schematic symbol. Hola! Done with the first project of your component library design using EasyEDA. I hope you loved and enjoyed the process of creating your first component library in EasyEDA. If you have any questions or any doubts or any suggestions, feel free to comment down below in the comment section. See you again in the next video. Until then, tune yourself to make a difference.